For the calculus approach, we have to write, ax star, and then we subtract, right, by the b, and we need to find the norm of that vector. So I would write the following form. I have the norm of a, and then multiply with the a, b, c in here, because the system, this system, has three variables, a and b and c, okay. And then in this case we have and then we subtract with the b, let's say b is the x coordinate in here, and then we find the norm, right? We find the norm. So basically each time I just demonstrate the first row, and then for the rest we do similarly. So the first row, for example, we have 1 in here, 0, 0 in here, right? And the first entry of b is 0. So basically I will have, for the first coordinate of this vector, I will get the following one. Just a times 1, right, plus b times 0 plus c times 0, and subtract the 0 in here. You see? And subtract the 0 right here. So basically, I just take coefficient in here, I multiply with this, right, and then I subtract 0. So basically the second rows would look like, I have a in here times 1, right, plus b times 2 plus c times 2 square, and minus the second values of b is what? Is 15. Is 15. You see this equation? So 1 to 2 square and 15. So I have 1 in here, 2 in here, 2 square and 15 in here. That is corresponding to the second equation, and so on, right? And I have a times 1. Okay, let me change. Okay, that's fine. And then b times 2 square, not 2 square, 4, plus c 4 square minus, for the 4 we need to check, that is 30, minus 30. And then for the next one I have a times 1 plus b times 6 plus c 6 square minus 50, I guess 50, yes, and then 65, and then 70. Okay, I write 65 in here and then minus 70 in here so that I will not forget. We still have two equations which will give us two rows of this. I have a times 1 plus b times a plus c times a square, and then a times 1 plus b times 10 plus c 10 square minus 70. And then we calculate this norm, right? We calculate this norm, and this norm is equal to, is very huge, but that is fine. I have square root in here, so I have square root. The first one is square of the first coordinate, but that is just a square, right? The second one is a plus 2b plus 4c, and then minus 15 square. The next one plus a plus 4b plus 16c minus 30 square, and then plus a plus 6b plus 36c minus 50 square plus a plus 8b plus 64c minus 65 square, and then plus a plus 10b plus 100b minus 70, and then square. You see? So that is the function, and our function depends on three variables, a and b and c. So we need to minimize this function. And of course, we as we discussed before, so we just need to minimize the function under the square root, right? And we need to work with partial derivatives. Agree? So we need to work with partial derivative. All right, so let's repeat this. The first step we need to find. So now I think I will just erase the square root. Okay, because we just need to minimize the square of the square root. So let me erase the square root in here. Okay, and that is our function. Let me denote this by f of a and b and c. Okay, so I have function of 3 variables. The first step we need to do is find partial derivative. We need to find partial derivative. And set them equal to 0. And set them equal to 0. So I remind you, this step is just to find critical point, right? Critical points. So let's do that together. Let's find partial derivative with respect to the a. So because we have 3 variables, we have 3 partial derivatives. So let's say f with respect to the a. You differentiate this function with respect to the a. Oh, I think I saw one typo in here. This should be c. This should be c. So let me fix that. This should be c. Okay. When you differentiate with respect to the a, you look at b, c as numbers. So derivative with respect to the a of b and c would be 0. Okay. So the first term right here, the a, will give you 2a, right? Give you 2a. The second term right here with the 2, so I use the chain rule. I have the following one. I have plus 2 times, and then a plus 2b plus 4c minus 15. Use the chain rule. And then the second one, I also use the chain rule. I have 2 times a plus 4b plus 16c minus 30. Okay. The next one, also the chain rule, plus 2 times a plus 6b plus 36c minus 50. And then so on. The next one is 2a plus ab plus 64c minus 65 square. And the last one is 2a plus 10b plus 100c minus 70. So that is the equation, the partial derivative with respect to the a. You see, here you can see a everywhere, 2 everywhere, right? 2 everywhere. When you set this equal to 0, you can simplify 2. So basically, we have less computation. Make sense? Anyway, we'll see the following formula. Let's simplify this, and I set this equal to 0. Okay, so I ignore 2. Okay, I ignore 2 in here. I don't have 2 anymore. And I have the following one. For the a, so I have 1a, 2a, 4a, 6a, 7a, 1, 2, 3, 4, 5, 6a. So I have 6a. 6a is 6. The number 6 is corresponding to 6 equations. Don't forget this. Because you have 6 terms in here. You see this? You have 6 terms in here. So each time, you have, 1a. So you have 6a. All right. So for the b, first you have 2b, you have 4b, 6b, 8b, 10b. So what is that? What is that? Actually, you just take sums of all coefficients in here. You see this? the first column, the second column. You know what is 6? 6 is sum of 6 ones in here. Look at this. You have 6 ones in here. You see? For the B, you have sums of coefficients in here. And for the C, you have all this right here. And you can see the free coefficient looks like this, sum of all free entries on the B. So basically, I can write the following one: plus 2 plus 4 plus 6. You know, I would like to write 0 in here too, because, you know, that is one value. So after this, we can generalize, you know, the formula. Makes sense? 6 plus 8 plus 10, B. And then for the C, you can see that is 2 square. That is, okay, let's say 0 square. 0 square plus 2 square plus 4 square plus 6 square plus 8 square plus 10 square. And then that is the coefficient of C, okay? And then the free coefficient, I just write in another side. So basically, that is sum of all entries in the B. Sum of all entries in the B. Let's see, that is 0, 15, 20, 30, 50, 65, and 70. So I have 0 in here, plus 30, plus 50, plus 65, I guess, yes, 65, and plus 70. So the first equation looks very simple, right? Okay, here's the key, right? The coefficient of A right here is the sum of, is the number of what? Of equation. Okay? The coefficient of B in this situation is sums of the x values, right? This one is sum of squares of the x value. Is that correct? And the free coefficient right here, that is sum of entries, or let's say sum of values of sum of the y values. So now, you know, even you don't need to differentiate, but you still can find, you know, the first equation when the partial derivative with respect to the A equal to 0. So you just take sums of all these values, the number of equations, the x values, the squares of x values, and then the sum of y values. Make sense? So I will not simplify this. I hope you can do that yourself. Okay, so you can find all these values, and then you have one linear equation. So this is the first our linear equation. The first linear equation. All right, let's work on partial derivative with respect to the B. Okay, so I need to find FB. What is FB in this case? So we just differentiate with respect to the B. For the first, I don't have any B because, you know, 0 over there. So I just say yes, 0. For the second term, in here, I differentiate with respect to the B. I need to use the chain rule. Okay, so if I differentiate, okay, let me do that for each term, and then we sum them up, and again we will generalize, right, like previous equation. So let me make this. I just want to copy this, right? Okay, where is the copy? I don't see the copying here, but I think I can move this. Interesting. Oh no, that will just cut off, you know, the formula. Okay, so let me write in here, and then we copy to the next. So I want to find the derivative of this with respect to the B. I will have 2, and then A plus 2B plus 4C minus 15 times 2. Well, we have 2 right here because 2 we differentiate the inside, we get 2 in here, right? And this 2 will go here. So basically, what is that? You have 2 times of 2. This is the x coordinate. Don't forget that. The x value. You see that? X value for the first term. So, alright. And then similarly, I can find the derivative, partial derivative with respect to the b of the second term, right? Now, I hope you can close your eyes and write that term. That is 2 times and then what? You copy the whole thing in here. And then plus 16c minus 30. And then you add 4, which is the x value, right? The x value. Makes sense? So basically, when you calculate for each term and you sum them up. And then you set it equal to 0. Okay? So again, 2 will appear as common factor. You can, when you set it equal to 0, you can simplify that. Agree? But each time you have to multiply with this guy. 2, the x value in here, the x value in here. Alright? So let me write it down. Oh my goodness, I cannot see that. Yeah, I think I can see that right here. I can copy from this formula. Okay? So that should look like 2 times a plus 2b plus 4c minus 15. The next one is 4 times because the next x value is 4. Okay, a plus 4b plus 16c minus 30. You see? And then each time when you increase that, you just add in here. You have 6, and then a plus 6b plus 36c minus 50. And then you move to the next data point, you get plus 8, a plus 8b plus 64c minus 65, and then plus 10, a plus 10b plus 100c minus 70. And you set this equal to 0. I would like to mention here, I already simplified 2. So basically, we would have 2 times in here, okay? Don't forget that. 2 times in here, multiply with everything, and when we set it equal to 0, you just simplify 2. So I guess now you can write the third equation, right, for partial derivative of f with respect to the c. I will not explain that. I just write the equation for you, so I hope you can guess. The f of c, that should be 2 times also, right? But again, I will simplify 2 when I set this equal to 0, okay? When I set this equal to 0. The first term, instead of 2 in here, right? Instead of 2 in here, I will have 2 square. Instead of 4 in here, I will have 4 square. Instead of 6 in here, I will have 6 square. Instead of 8, I will have 8 square. Instead of 10, I will have 10 square. Makes sense? So I write real quick 2 square in here, and then a plus 2b plus 4c minus 15. You know, 2 square. I write 2 square because I want to keep the that rule. Actually, we need to write like, instead of 4, I write 2 square. It would be easier for you to imagine, right? So the next term would be 4 square a plus 4b plus 16c minus 30. And then the next term, let me erase this. The next term is plus 6 square, and then a plus 6b plus 36c minus 50. Okay, and then plus a square, a plus 8b plus 64c minus 65 minus plus 10 square, a plus 10b plus 100c minus 70, and equal to 0. And multiply with the 2. So basically, you already have, 3 equations. But again, like the first equation, I would like to generalize the second and the third equation so that you can see, some principle to write a system of linear equation for such problem. Okay, so let's generalize. Let's see how the second equation looks like in here, or maybe just work with the third one, because anyway, yeah, let's work with the third one, right? So let's find the coefficient of A. The coefficient of A looks like 0 square plus 2 square. Let's say I'm talking about the third equation, okay? The second equation looks will be the same. 2 square plus 4 square plus 6 square plus 8 square plus 10 square. And that is the coefficient of A. You see? What is the coefficient of B? The coefficient of B should look like 0 cube plus 2 cube plus 4 cube plus 6 cube plus 8 cube plus 10 cube. That is the coefficient of B. You can see that. Why? You have 0. I write 0 cube because I want to keep, you know, the first data point. But for the second one, why we have 4 square? 4 square and 4, we have 4 cube. You see? 2 square with 2, I have 2 cube. Makes sense? I mean, for the B right here. Each time for the B, I have 6 with the 6, I have 8 with the A, I have 10 square with the 10, so I have this one. And of course, you can guess, with the C, you would increase, right? You would increase the power in here, so you get plus 0 to the 4, plus 2 to the 4, plus 4 to the 4, plus 6 to the 4, plus 8 to the 4, plus 10 to the 4, and then C. Makes sense? You see this? And then for the free coefficient, it also has some rule right here. Okay, so I copy in here. So this is what? This is the square, right? And then you copy this. You get 2 square plus 2 square times what? 2 square times. Okay, I write 0 square. I write 0 square. Times the first one for the 0. Okay, I want to keep that. That is 0 right here. Okay, so that is 0 plus 2 square times the y coordinate for 2. What is the y coordinate? That is 15 plus 4 square times what? Plus 4 square times 30. And then plus 6 square times 50, and plus 8 square times I think that is 65, and plus 10 square times 70. So that is the third equation. Please look at this one more time. There is some rules right here, right? For the C, so you work with the square. So that's why you have Z. The first coefficient of A is 0 square, 2 square, 4 square, 6 square, 8 square, 10 square. And then for the B, you just increase to 1, you get cube. And then for the next one, you get 4. But for the free coefficient, you just multiply all this. So basically, what is that? Look at this. What is this? So that is just, you know, if I write it in the form of vectors, right? That is just scalar product. Is that correct? The scalar product of what? Of 0 square, of 2 square, of 4 square, of 6 square, of 8 square, and then of 10 square. Scalar product with the B, right? With the B right here. With 0, 15, 30, 50, 65, and then 70. So that is the free coefficient of the third equation. And now I guess if you follow the same idea, so you can rewrite the equation FB equal to 0. FB equal to 0. But the degree in this case will be less, right? So that will start from the first. And then here would be the second. And here would be the third, right? And in here would be the first one. Make sense? So actually, now after this example, if even you don't know about partial derivatives, you still can write 3 equations of this system, and you can find A and B and C. How about that? How about that? So let me write the second equation for you, which is for FB equal to C equal to 0. Okay. So for that, I will collect all this one. I have 0 plus 2 plus 4 plus 6 plus 8 plus 10 A. The next one I will have 0 square plus 2 square plus 4 square plus 6 square plus 8 square plus 10 square B. You see that? And then the next one for the C, I would get 0 cube plus 2 cube plus 4 cube plus 6 cube plus 8 cube plus 10 cube C. And the free coefficient would be 0 times 0 plus 2 times 15 plus 4 times 30 plus 6 times 50 plus 8 times 65 and then plus 10 times 70. Make sense? So, basically, we already know the principle how to write these 3 systems of linear equations even without computing partial derivative C, partial derivative A, and partial derivative B. Okay, and once you solve this system, you can find the ABC. You can find the ABC right here, ABC. Or basically, this serves like A star, B star, and then C star. And that's what you can determine, the polynomial. P x equal to A star plus B star x plus C star x squared. All right. So since I have only one correct, solution from homework, I would suggest you to solve this problem to the end. I already wrote 3 equations for you. Okay, so please watch this video and copy these 3 equations and solve the system of linear equations with respect to the A and B and C. And please send me the solution. Okay, I would love to see the solution, by the end of this weekend, so that we can go ahead to another topic, right, with the least square problems. All right, thank you, and hope to see a solution from you. Bye bye.